Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 4 for the March daily LeetCode challenge, and we again have a medium question in front of us. Let's quickly see what this question is. It's going to be a very simple question. It's one of the shortest question that we have seen till now in March. Let us quickly see this. 1780, check if number is a sum of powers of 3. So what you have to do is, for a given number n, basically what you have to do is you have to try to arrange it in terms of powers of 3. Okay, and the power should be distinct. So if you see the exact words, given an integer n, return true if it is possible to present n as the sum of distinct powers of 3. Okay, remember the word distinct is very important. We all the powers that we have to take is going to be distinct. So see this example first. Here they are writing 12 is equal to 3 power 1 plus 3 power 2. Okay, so here the idea here is, see, 1 and 2 are unique. Okay, that is, you cannot repeat 1 again. So 3 power 1, once it comes, you cannot repeat it again. Similarly, once 3 power 2 comes, you cannot repeat it again. So in that way, if you see, we are able to get 12 by adding two distinct powers of 3. Okay, that's what they're trying to say. If you're able to do that, you have written true. If you're not able to do that, then in case you have written false. And they explain that a power integer y is the power of 3 if there exists an x integer x such that y is equal to 3 power x. Okay, so yep, that's what they're trying to say. So basically, for any given n, we have to like try to show that, we have to try basically if we can represent this using distinct powers of 3. If we are able to do it, we have to return true, otherwise we'll have to return false. So if you see the constraint, remember in this kind of question, always the constraint is very, very important, because that will play a very major role in your solution complexity. Okay, so in this case, if you see it's going to 10 power 7, so mostly people will not show you the calculations, but see, I will try my best to show you all the possible calculations which you should be actually doing if you are getting this question in a face-to-face interview. Okay, remember these things are important, because here, if you're not doing these calculations, what I'm going to show you now, then your solution will never be efficient. Let me give this you in writing. Okay, so let us quickly dive into it. See, we are given 3 power n. Okay, see, that is, what I'm trying to do is, I'm just trying to see at max how much, what is the max power of 3 that I have to go to capture the final result. Okay, so in this case, I'm just trying to match n. Okay, the highest value of n, so highest value of n is 10 power 7. I'm just trying to see what could be the highest power of n. See, n is different here. Okay, n means the highest power of 3 basically. Okay, I'm just trying to see which is the highest power of 3 which will be able to match this particular number. Okay, just trying to understand how much far we have to go. So if I do this calculation, I'm applying log on both sides, you will get that. See, if you apply log on this side, you will get 7, because log 10 base 10 is equal to 1. Okay, so you'll get only 7. Similarly, here you will get n log 3. Okay, if you solve this, you will get n equal to 14.67. So basically, if you like round it off, you will get n equal to 15. Okay, so the idea here is, see, n equal, if you see n equal to 15, I'm just calculating that, we will get this number, which is equal to 1.43 into 10 power 7. Okay, but in this case, in our case, we only need till 10 power 7. So idea here is, we should never be crossing 14. Okay, so actually we have to go from 3 power 0 till 3 power 14. We should never be crossing 14, because once you cross 14, there is no possibility for you to get the answer, because if you see 3 power 15 is basically even greater than what you are going to get. Okay, as simple as that. So you have to always try, what I'm trying to say, see, here 3 power 0 plus 3 power 2 plus 3 power 4. So like this, you have to keep trying till n equal to 14. That is, yeah, till 3 power 14. You should not go beyond that. Okay, that is something that I want to tell you. Okay, let us quickly begin what we can do here. See, so what I'm doing is, defining a recursive function. So as you know, whenever we define a recursive function, always you have to first of all, think about what could be the stopping conditions, because it's a recursive function. Basically, recursive function means anything that calls itself. Okay, so first of all, you have to think of where we have to stop. Okay, so these two are going to be my, stopping conditions. See, whatever I have defined here, see, this is going to result. That is, see, I means what is the power of I, that is what is the power that I applied before. Okay, and after applying that, what is the result. Okay, if you see, I'm starting this with like this. Okay, function n comma 0, n means the value that I'm getting in the input, and 0 means we have to apply 3 power 0 next. Okay, so see here, if result equal to 0, we have got the answer, return true. If I is greater than 14, that is, we have reached I which is greater than 14 now, in that case we'll have to return false. Okay, now you will ask me, what about result, going to negative. See, result will never go to negative, because while calling this function, we are ensuring that fact. Okay, in this case, if you see, always n is positive, so the first call will never be in such a way that result is negative. Similarly, in the subsequent calls, I am always ensuring that whenever result goes below 0, we do not make any function calls. Okay, that is something that I'm ensuring. So let us see what we are doing. I am going from I till 14. Okay, so this particular variable power, it will go from I till 14. Okay, so whichever is max, it will go from I till the value 14, right? Now what I'm doing is, result minus 3 raised to power 3 raised to power this particular variable. Okay, so we are getting the result. If this result is less than 0, that means see, it power will keep increasing, right? So if this power itself it is going less than 0, then it doesn't make sense to continue further, so we'll break out of this loop. Okay, if this is not the case, what we'll do a recursive function call. In the recursive function call, what we are doing is we are passing the rest is going to be kind of a residue in the sense like the remaining result. Okay, in this case, if you see after subtraction result, whatever value that you are having, that you have to pass here, and you will have to do power plus 1. Okay, as simple as that, because from that power onwards you have to try and next. Okay, as simple as that, right? Yep, whatever you're passing here, from that value onwards you will try, you know you will try to subtract that. Okay, as simple as that. So I'm passing this. So this is a recursive function call. If you see, one of these values will be returned. Okay, one of these values will be returned. If the value true is returned, if you see here we are comparing with a true, what we'll do is we'll stop any further iteration. Remember, we are inside a for loop now. If we already know that we have got the answer, since in this question only we have written true and false as answers, so I'm directly returning true. That means if any iteration is going on, I don't want to go to the next iteration, so directly I'm returning the true. Okay, as simple as that. And then yeah, that is it, right? If it is not returning true, then it will go to the next iteration and so on. Once this whole for loop completes, okay, once this whole for loop completes and we have not written true, in that case we have to return false. Okay, as simple as that. So this is how the initial function call is happening. We're passing n and then we're passing 0. So if I can show you some of the outputs, see this case, this is how it is happening. For the example number, let us go to 1. See, yeah, if you see it is coming 1 and 2. Okay, then we are getting the answer, right? So 3 power 1 plus 3 power 2, if you do, you will get this particular answer, right? 3 power 2 is basically 9, 9 plus 3 is 12, right? Now if you see the case number 2, we are getting it like this. So 3 power 0, which is 1, 1 plus 9 plus 3 power 4. Okay, then you will get this particular answer. Okay, that's what we are getting it. And in the last example, we are not getting the answer. That's why if you see, we are directly returning false. Okay, yep. So yep, if you see in my solution, what I'm showing now, I've not included those print statements. But if you want the print statements basically, so what you will have to do is you have to add an initial variable in the function call. Okay, I'm adding additional value s, which will store how many, what are the previous values that we are using. Okay, so it will show like that, and when we are making a new function call, we have to keep adding them. Okay, that's why we are getting this kind of result, if you see. Okay, yep, we are getting it like this. So it will tell us like when we are reaching the final answer, which all variables, so which all powers we already subtracted from the initial answer. Okay, from the initial input. So that way it will be getting captured. If you want, I can give you the solution also, but both the solutions are same. The second one that I'm showing you is basically I'm just trying to show some output, that how the final result is coming. For that reason, I've added some additional parameters. Okay, as simple as that. So this S that you're seeing is the additional parameter, and this is the original solution where we are not taking any print statements and we are not storing those values like which all powers were subtracted. But finally, if the result is true, we are just returning true. Okay, as simple as that. So yeah, that was all for this particular video. This was, I will say, slightly, see, it depends on, see, because the topic also, if you see, they've given maths. Okay, they have not given even recursion here. Okay, so yep, this was, I will say, slightly on the difficult side. Difficult in the sense, if you have the idea you can do it, but it's very difficult to identify if we can solve it using recursion. Okay, so see, that's why I'm saying the idea will only come if you take this kind of calculations. After you make this calculation, you get the n equal 14, you will now then realize that yeah, from 0 to 14 definitely is doable in a recursion. Okay, definitely it is doable. So after seeing this value only, you will get to know, okay, recursion can also do this. Before that, I don't think you will be able to understand. Seeing this, you will not be able to predict whether, okay, a recursion is possible or not, because many will think that, okay, recursion will get time limited exceeded error. But only when you do this kind of calculations, you will get to realize that. Okay, remember, this n what you're getting here and this n what I'm showing you is different. Okay, you should not be comparing the two. Okay, let me make it like something 10 raised to power p, maybe. Let me make it, because both are different, right? I'm just trying to say what is the highest power of p I need to go beyond this. Okay, that's what I'm taking. Okay, highest power of 3. So yep, that's what we are getting. P equal to 14.67, which if you round up it will be 15, and 3 power 15, if you see, is going to be around 1.43 10 power 7, which is greater than this. Okay, so we have to, that's why, limit ourselves to less than 15, that is 14. Okay, so we'll go from 0 to 14. We will not cross 14. Okay, that's what we're trying to do. If you see in this case also, we are never trying to cross 14. Okay, the highest value that will go is 14. Okay, as simple as that. That's why if you see, this is also one of the base conditions. So yeah, often that was all for this particular video, and I will give this solution in the comment section, and the question link will be in the description. Please go through it and let me know if you have any questions. And if you like my efforts, if you like the quality of this video, if you like, see, this is my 133rd 133. So from last 133 days, I am continuously making the videos. I'm continuously uploading them for you. So if you feel you are getting to learn something new, if you feel that you are getting to learn something different on a regular basis, please do subscribe to the channel. This will ensure that multiple more people who do not have access to paid resources can get benefit out of this content. That is my only aim for which I am doing. Remember, it's always a win-win situation for both of us. You are also getting to learn something new. At the same time, I am also getting a reason to code every day. I'm also getting to learn something new every day. Okay, remember, if you are not coding every day, you may have the skills, but if you are not able to use them, then obviously they will no longer be with you. Okay, always remember, in sports as well as in coding, you'll have to keep practicing. You have to keep practicing. Once you leave it, you may have the skills, you may have some history, you may have some good records in past, but if you enter the game again, you will face that, yeah, you are not able to compete with others. That's why in sports as well as in coding, always you have to maintain continuity. You should be, doing that every day basically. Only then you will see some improvement. Otherwise, it's very difficult to improve in these kind of things. So yeah, that was all for this video, and please subscribe. That is my request. See you tomorrow. Thanks a lot.